Hello, welcome to everyone. This is the session related to interview questions and their explanations on the questions related to microservices, which are on Spring Boot. Okay. So as always, Ashok IT, always we are here for you to provide assistance to all the job seekers. And definitely this session is going to help you in your career path where you can crack your interview and you can, this session is going to help you. That's in context here. Okay. So at the end of this particular session, we have provided our email ID and our contact details. Just get back to us on in case of any feedback or any other topics you are looking or any other things, a collaborative platform which we want to build here. Okay. So without wasting our time, we'll go further. Okay. So definitely we are going to provide you soft copy of this particular session to everyone. Those please reach out to us. We are going to provide this. Okay. So without my request here is please go to the end of this particular session, and this session will going to be helpful for you. So the first question, which is what are microservices? What are the benefits? This is the first question you will get in an interview. By default, microservices is a design pattern where we can split the large application into smaller chunks, smaller parts or smaller chunks, where each and every chunk is a independent and loosely coupled and deployable unit. That is called as a microservice. Okay. This is how we can develop in Spring Boot, and every Spring Boot application which is having at the rate of Spring Boot application annotation, that itself is called as a microservice. We don't have any separate annotation called as at the rate of microservice. Every Spring Boot application that is having at the rate of Spring Boot application, that itself is called as a microservice. And each of these services represents a specific business functionality, a specific business feature, and that communicates via APIs. It can be REST API, it can be different kind of communications, right? And the benefits of microservices are, the first benefit is a scalability. So this is the top advantage using microservices architecture. Okay. So what exactly a scalability is? In the legacy designs or legacy architectures, we can provide a scaling, either vertical scaling or a horizontal scaling at entire application level. Generally, scaling means when we are getting a lot of requests, what we'll do here, we are going to deploy our application into multiple units, and we are going to control through load balancer, where the request will be tunneled through different servers, and where we are going to provide a solution to the high performing application. But in case of legacy architecture, we can achieve either horizontal scaling or a vertical scaling at application level. But whereas in microservices, we can achieve at individual service level. So that in a business, whatever the top selling features are there, we can provide our more hardware to that particular feature. So that is the advantage with respect to microservices. And flexibility, we have an option where each and every microservice can be developed in different technologies. Some service can be developed in Java, other service can be developed in .NET, other service can be developed in mainframe system, other service can be developed in C++. Like that, we have a heterogeneous communications is going to be possible in case of flexibility is concerned. After that, resiliency. When one of the service is having a problem, it will not impact the entire business. It's not going to impact the entire business system here. Okay. So, for example, I wrote a code which is going to infinite loop. Then it is going to impact the entire application. Rather than impacting the entire application, we are going to only that service is going to be impacted. Rest of the business will be good here. Okay. After that, when we are developing parallelly, so which is reading faster development and faster deployment here. So services can be deployed independently. So this is the microservices introduction as well as benefits using microservices. At the same time, there is a question we'll get for you. What are the challenges you face in microservices and how you'll overcome? That's a question we are going to get it. So the first challenge is with respect to complexity, where we are dividing the business into smaller services, right? When the number of services are increased, so their intercommunication is a big challenge here. And also data consistency. Every service is independent. So whenever there is a failure is occurred, to manage the consistency on the data among multiple microservices is also a challenge. In legacy architectures, we used to have a distributed transaction with a two-phase commit, where we'll start a transaction, we'll do all the database calls in one transactional block, either will commit or will roll back, so that data will be consistent. So where two-phase commit protocol is going to help us in that particular context in the legacy architectures. But whereas in microservice, we don't have that kind of flexibility. So what we are going to do here, data consistency is going to be a challenge. Now, how to overcome this is the first option is whenever there is a failure is happening, we should feel that the failure is intermittent. Maybe some kind of environmental problem, or it can be a data problem, or it can be network issue, which can be resolved after some time. So what we want to do here, whenever a failure is occurring, we don't want to roll back the other success scenarios. We should consider this as a failure and we should retry the failure so that the failure can be attempted immediately. Just like when we saw Big Basket or Amazon, right? Whenever a failure is occurring, we can have an option of retry the payment so that we no need to roll back the order. We no need to roll back the inventory. Next one is distributed tracing as well as monitoring. So whenever an issue occurs, we need to track all the logs. We'll go to microservice 1, any error comes. We'll go to microservice 2, any error comes. Like that, we need to trace. That's also a challenge. So where we are having a ELK stack, Zipkin, and Sleuth, these are the other options where we can monitor and we can enable the distributed tracing. And deploying, where we have a multiple versions of microservices, and we need to build and we need to rolling updates, where we have a CI/CD pipeline with Jenkins or some other tool where we can achieve this. So some of the challenges, at the same time, we have an options to overcome those challenges. This is the high level context where I want to explain here. Next, how do microservices communicate with each other? By default, microservices can communicate via REST APIs or RPC communication, remote procedure call, or messaging system through event-driven architecture like Kafka, RabbitMQ, ActiveMQ, JMS, IBM queues. These are the different things here. In case of event-driven architecture or a message system communication, it can be asynchronous or it can be asynchronous. We can achieve both the types of communications, right? What is the role of API gateway in case of microservices architecture? Okay. An API gateway is a single entry point of contact here. Is a single entry point of contact here. So it is going to take care of all the requests which will traverse through this API gateway, so that we have a common entry point. We have a common entry point to all the microservices where we can aggregate requests and response, and we can have a load balancing. We can have a common code measures and also authentication. And if you have any rate limiting, bulkhead, any other things we can handle at a gateway level here. Okay. And also we have one more important point is during secure communication, every time SSL handshake is going to take a time processing, right? Whenever we have a gateway which have a HTTPS handshake will happen only once, and next upcoming request we no need to have a SSL handshake here. That is also improving the performance of the application, right? What are the differences between monolithic and microservices architecture? In monolithic application, all our services are like front end, JavaScript, JS, HTML, all these are the front end, controller, service, data access layer, business logic layer, external communication layer, and data access layer. All these are packaged into a single unit that is called as a monolithic application. Something like we can correlate in a combined family, right? A father is having two sons, father and mother, and two sons and their families like grandsons, grandchildren. All those are staying in one family where they will take the common areas like living area, kitchen, dining area, living area, all those things they will share, and everyone will have their own bedrooms and restrooms. So that is a typical correlation. I can tell that it's a correlation to a monolithic architecture. But whereas microservices, we are splitting into individual chunks or individual pieces, and every piece is independent, deployable service, and focusing on a business application. Like in the same example, father is staying in one location, elder son is staying one location, younger son is staying one location. Everyone have their own house. Everyone have their own living room. Everyone will have their own kitchen. Like that, everything is separate here. That is a typical general classification of a monolithic application as well as microservices architecture. Explain the concept of domain-driven design in the context of microservices here. Okay. So by default, this is an important point here. DDD is a methodology of designing a complex software application based on the business domain. It can be banking domain, it can be commerce domain, it can be healthcare, it can be any of the domain. So we need to split that into domains and subdomains, and we need to know the boundaries of each and every service. What is the input? What is the output? What is the critical? And if it is the service is having any dependencies, like all those things, case study, we are going to study that, and we are going to organize the code across these domain concepts and separating them based on the software, based on the hardware, based on the sales, based on the implementation. All those things factor into the picture, where domain-driven design is a best case for achieving microservices architecture. Next, how do you handle transaction management in microservices? Just like I mentioned just previous to that, in a limitation of microservice architecture, by default, transaction management is not possible. Not possible in the sense, how we used to have a distributed transaction in legacy architecture of starting a transaction, either commit or rollback. Instead of that, we need to retry the failure. Instead of rolling back the other success scenario, we need to retry. For example, if you don't like this design, or else if retrial is also exhausted, then some of the design patterns like Saga design pattern came into the picture, where it is going to come with a flow orchestration as well as workflow based Saga. So these are the two patterns here in Saga design pattern, which will comes with different smaller chunks. And whenever every microservice is having two APIs, for example, I say ordering system, right? Create order, reverse order, create payment, reverse payment, update inventory, reset inventory, right? Process shipment, cancel shipment. So like that, every microservice should come with two APIs, one with the positive flow, another one is with the negative flow. And we should execute these compensating APIs based on which failure of any microservice. For example, if a payment is failed, now we need to revert the payment, we need to revert the inventory, reset inventory, and we need to reset the order. For example, at the time of shipment, order is getting cancelled. We need to cancel the shipment. We need to reset the payment. We need to reset the inventory. We need to reset the order. Something like that, we need to correct the data. That is a approach in case of microservices patterns here. Okay. How do you design a microservice for a high availability? This is a very popular interview question. So I'm designing an application and it is having lot of business critical application. How do you achieve high available microservice here? Okay. So what is the option is, we need to create multiple instances for service and deploy them across multiple available zones here. Ensure that services are stateless. Assuming that, for example, today here YouTube is there. Today YouTube is there here, right? In YouTube, India one data center, US one data center, Europe one data center. So that I am splitting my YouTube into different data centers where I'm going to control the load here. Okay. And also we are going to implement circuit breaker. Whenever a failure is there, we don't want to cascade the failure. We should have an option to continue with the flow here. So that is how we are going to design a high available microservice, which is having to deploy into multiple units and surrounded by a circuit breaker with respect to a load balancer, and we are going to shift the load. So that is the option of achieving high availability in case of microservices. After that, what is the how to manage service discovery? By default, we are not going to call a microservice with the port number, because to achieve a loosely coupling, we need to call a microservice through a service name rather than the port number. Assuming that, for example, I have a Paradise Hotel is there, right? Now Swiggy and Zomato, we can order to Paradise Biryani through Swiggy and Zomato. In case of Paradise change in URL or a port number, no need to change Swiggy and no need to change Zomato. So they are connecting to service registry, and service registry will handle that change. So service discovery can be implemented like Eureka, Zookeeper, Consul, and which will help loosely coupled systems. And how to ensure backward compatibility in microservices. For example, yesterday there is a one version and today we released a change, but the change is not working fine. How do you ensure backward compatibility? What we are going to do here, we are going to manage the versioning numbers like 1.1, 1.2, 1.3, 1.4, or major version dot, minor version dot, patches, like that. A universal standard of versioning numbers like major version dot, minor version dot, a patch, something like that. And we are going to design our interfaces in a generic way so that you don't need to change any concrete interfaces, abstract interfaces to achieve loosely coupled nature here. After that, what are the common patterns in microservices design, where we are going to have database per service Ideally, microservices recommends that every database will have its own database. Every service will have its own database. Sometimes it's possible, sometimes it may not be possible. In that case, we are going to use shared database pattern. Okay. Also, event sourcing, by default, event driven architecture, where I am communicating a particular microservice, which will publish an event, and that event will be consumed by the one more microservice, where I can replace with Zookeeper or RabbitMQ, and we are going to communicate two microservices with messaging systems. And CQRS, command query and responsibility. In any of the system you take, the writes to the database are minimal, reads to the database are maximum. If you take Amazon, right, lot of people will query rather than inserts and updates. So CQRS is going to achieve a better high available system where reads are reading from one database, writes are writing to another database, so that we are going to have database synchronization between databases. That CQRS is going to help you how to synchronize the databases, how to maintain the consistency on the database using replication algorithms, SharePlex or other stuff here. Okay, right. What is a circuit breaker in microservice and why it is so important? A circuit breaker is a pattern to detect and handle a failures in microservice. Okay. For example, I am designing a microservice. I know that sometimes it may fail. So when one service is failed, I don't want to stop the entire flow. So what I'm going to do here, I'm going to come up with a one more way of, okay, if the service is down, whenever the service is down, what exactly the background operation, fallback API. For example, I have a discount API. I wrote a good calculations on the discount, but there is a problem in the discount calculation. Whenever discount calculation is problem, I'll stop the discount service. When the discount service is stopped, I should continue the regular order, right? I should continue the regular order. So what I'm going to come up with that, I'm going to have a fallback logic where discount is equal to 0, so that it will be continuously seamless flow. Those who worked on this area, they will understand, guys. If they don't work on this area, I have a lot of workshops on each and every topic in microservices. You can go through that every workshop on each and every topic, and you can get a lot of details here. After that, how do you implement secure communication between microservices here? So where a TLS, which is a HTTPS communication, where encrypting the data and authenticating at client and server, API gateways, and OAuth, something like where we are going to have OpenID Connect for token-based JWT, and network segment and service mesh, something like that. Network level security, where we are going to ensure that we are getting the request from a valid hardware, something like we can control over etc host file, where we'll make sure that if the requests are coming from a specific domain, then only you can take it. Other domains coming, you can ignore that. So these are the different levels of security achieving between the communication. How do you deal with service failures? Whenever service is down, how do you deal with that? Circuit breaker, one of the design pattern. Retry is another design pattern. Bulkhead is another design pattern. So where we are going to have to implement this, Spring Boot comes with Hystrix and Resiliency 4J to handle these kind of service failures here. How do you ensure a security in microservices architecture, where we are going to implement OAuth and JWT, where we are going to achieve this code at a API gateway level, so that any microservice share the user detail service object across multiple services, so that you no need to write a code of authentication at each and every microservice, and we are going to have fine-grained authorization at individual service level. What is the role of containerization in microservices? Containerization is something like help the microservices along with the dependencies, make it to portable and consistent across environments here. So for example, I have a Docker. I can deploy on any other operating system, which concludes of our dependencies, our jars, our runtime, everything we will only set up. Customer no need to install manually any other stuff here. Okay, so that it simplifies the deployment as well as simplifies the scaling here. After that, how do you handle logging in a microservices architecture? Just now I mentioned here ELK stack, Logstash, Kibana, and Splunk, where it is going to have a distributed logging. I have taken a workshop on ELK stack so that you can go through that implementation of ELK stack with Spring Boot. You can go through that actually. How do you monitor a microservice? Where we are going to use Prometheus, Grafana, Datadog, along with that Zipkin and Jagger, and these are the tools where we can monitor the health check, monitor the error rating, monitor the CPU usage utilization, monitor the thread pool, and monitor the deadlock situation. Everything we can monitor. What are the tools you can use for CI/CD pipeline? Where we can use Jenkins, GitLab, Travis, Agro, Knacker. These are the tools. Mostly a lot of people will use Jenkins. It's easy for us to achieve that. What is the centralized configuration in a management, centralized configuration management? By default, all our configuration in microservice, we are going to have a centralized environment tree, that is Spring Cloud, so that any change, refreshed scope is going to take the latest and greatest values. You no need to down any of the service here. Okay, so it is achieving the efficient deployment and efficient configuration. How do you ensure observability in microservice? Just now I mentioned Prometheus and Grafana. These are where we can observe our microservices here. How do you handle failures in microservices architecture? Just like I mentioned here, circuit breaker, retry mechanisms, proper exceptions, and fallback methods, or these are the options handle failures in microservices architecture. After that, how do you scale a microservices here? Microservices can be scaled independently based on the load. Something like horizontal scaling, like more instances of a service, or a vertical scaling, something like increasing the CPU, RAM, and all those things. So where we can achieve using Kubernetes or Docker Swarm, all those things here. How do you ensure high performance in microservices? It's a very, very important interview question, guys, here. Okay, where we are going to optimize the microservice by reducing the latency, optimizing the database queries, asynchronous messaging, caching, load balancing, and scaling. So by default, when we are optimizing the database query, lot of query time will be reduced, and caching, so that database lookups will be reduced, asynchronous mechanism, parallel processing, and load balancing, shifting the load or balancing the load, and scaling the services. All these are the variety of patterns or variety of designs in achieving the high performance of a microservice here. What is the rate limiting and why it is so important? So rate limiting is a API or a design controls the number of requests that comes to a microservice over a period of time, so that it helps the overhead and ensure usage of resources. For example, Amazon sale is there, okay, where I can control 1 lakh requests, concurrent requests I can accept. Behind that, I cannot accept, so that I can control that, so that my hardware will be in a safe position. What are some common security vulnerabilities in microservices and how do you address them? By default, SQL injection, cross-site scripting, insecure API endpoints, insufficient authentication. So we are going to use encryption and regular audits and OAuth and JWT. So SQL injection, where we need to make sure that we are going to completely write the SQL queries in the, in our area of microservice area only, and we are not going to have any cross-site scripting, something like that. We are going to have a CSR of security. We are going to have to avoid the cross-site scripting, and our each and every point should be secure by having authentication and authorization, something like user details object and also at the rate of roles, at the rate of secured or has any role, all those things we are going to take care here. What is the event-driven architecture? So event-driven architecture to achieve a microservices communication through asynchronous mode here. So this I had taken a workshop on event-driven architecture on an e-commerce platform. So just go through that. It promotes loose coupling and it will scalable and reactive system using Kafka and RabbitMQ here. And what is a strangler pattern in case of microservices? Strangler pattern is a technique gradually replacing a monolithic system into microservices by routing traffic into new microservices while keeping the old components active until the migration is complete. By default, one of the real-time example I can take, income tax returns, ITR website. So Infosys, I'm not sure the company who recently they created a new ITR returns. And some of the scenario, new software is not working. Some of the scenarios it is not covering. So what they did here, they enabled the old system for those kind of scenarios. So both new system and old system, both are up and running. And whenever a customer will try on the new system, if it doesn't work, he will try on the old system. So that both will be covered here. And gradually all these scenarios will implement and will shut down the old things here. So keeping both new microservice and old logic in place and shutting down the old logic once migration is complete. Okay. Also, what is the principle of least privilege and how does it apply in a microservice? Least privilege ensures that services, the microservices and users have less access to resources and the data. Something like we are going to achieve fine-grained authentication and fine-grained authorization by dividing that roles and a specific role, specific access level, so that we have a least privilege we are going to achieve here. What are the role of health checks in microservices? Health check, that is a liveliness where we are going to use actuators and helps that is a service is up and running and ready to accept the traffic and helps in automating in a monitoring and failure recovery here. I hope these are the top interview questions. By default, we covered 30 questions, which are top level interview questions for which covers 4 freshers. Just like completed the college graduation or post graduation and some experienced guys also. This session is going to help you. Okay. So by default, if you have any suggestions, any questions or clarifications or any other things you want to discuss, kindly drop out an email to vijay.ganta@ashokit.in. So my name is Vijay Kumar. So I'm with Ashok IT. I'll teach the topics of full stack that includes Angular and React and Spring Boot and microservices and design patterns in microservices. Okay. Finally, thank you everyone. And I wish you all the best for your entire career. Keep in touch. Have a great day. Thank you all.